Assalamualaikum and hi. Today we will learn about chapter 4, which is system resources. So, what is system resources? System resources is a tool used by either hardware or software to communicate with each other. Moreover, system resources can be used by users when open programs and applications, as well as by services which are usually started automatically by your operating system. So, there are 4 categories of system resources, which are memory addresses, interrupt request number IRQ, input-output addresses, and also direct memory access DMA channel. So firstly, I will explain about the memory addresses. So basically, a memory address is a unique identifier used by a device or a CPU for data tracking. This binary address is defined by an ordered and finite sequence, allowing the CPU to track the location of each memory byte. So it is to ensure software can then access this memory by using these addresses. In short, it will be a reference to a specific memory location used at various levels by software and hardware. Next is the input-output addresses. Each input and output device connected to your computer is mapped to a unique input and output address. These addresses are assigned to every input and output port on your computer, including USB, FireWire USB, FireWire, and etc. Having a unique address assigned to each port allows your computer to easily recognize and locate devices attached to your computer. Each device listens for these numbers and responds to the ones assigned to it. Thirdly is the direct memory access DMA channel address. DMA or direct memory access enables a device to transfer data without exposing the CPU to a work overload. With DMA, the CPU can process other tasks while data transfer is being performed. For interrupt request number IRQ is a signal from a hardware device on your computer to your CPU. When a hardware device needs the CPU to do something, such as move the cursor as you move the mouse, the device sends an interrupt request to the CPU. Some lines have a higher priority for attention than others. So, this is the interrupt request number for devices and associated function of interrupt request number. Next is the boot process. The boot process is a BIOS startup program checks hardware to make sure it is ready to be used. For example, to boot a computer, you have to turn it on. Once the computer power is turned on, the boot process takes place. During boot process, startup BIOS tests essential hardware components, which is POST or also known as power on self-test. Then, setup information is used to configure both hardware and software. Hardware components are assigned system resources they will later use for communication. Then, OS is loaded, configured, and executed. Hardware devices are matched up with BIOS and device drivers that control them. Furthermore, some application software may be loaded and executed during the boot process. In computing, booting, or also known as booting up, is a bootstrapping process that starts up operating systems when the user turns on a computer system. A boot sequence is the initial set of operations that the computer performs when power is switched on. The bootloader typically loads the main operating system for the computer. Next, types of rebooting. There are 5 types of rebooting. Firstly, hard boot. Hard boot, or also known as cold boot, is the process of restarting the computer after the power has been completely turned off. Secondly is soft boot, or also known as warm boot. It refers to restarting the computer without shutting it all the way down. For random boot, or also referring to an unintended reboot, it is happen when multitude of software and hardware problem. For reboot automatically is when reboot at a scheduled time after a power failure or kernel panic. It depends whether the reboot can be handled in software or firmware or hardware. Lastly is the error rebooting. That happen when boot process is error, the blue screen of that may occur. Next is the 4 steps involved in the boot process. Firstly is POST, or also known as power on self-test. It begins by reading configuration information stored in the IP switches, jump purpose and the CMOS chip and comparing that information to the hardware present. The routines are part of a device pre-boot sequence. Once POSC completes successfully, bootstrapping code is invoked. Secondly is the ROM BIOS startup program search for and loads an OS. It is most often the operating system is loaded from logical drive C on the hard drive. Thirdly is the OS configures the system and completes its own loading, where the OS loads software to control the mouse, a CD-ROM, a scanner and other peripheral devices. Lastly is the user executes application software. The OS finds the application software copies software into memory and turns control over to it. User commands the application software, which makes requests to the OS, which uses the system resources, system BIOS, and device drivers to interface with and control the hardware. Next is the configuration data and how it is stored. Startup password is required by computer during boot process to gain access to the PC. It is also known as power on password. Users may forget their startup password, so the best method to reset a BIOS password is to depend on what BIOS the computer has. So there is the ways on how to reset CMOS. Firstly, you have to use backdoor BIOS password, reset BIOS password using software, vendor-specific solution to reset BIOS password, reset BIOS password using hardware, clear CMOS using jumper, and also take out CMOS battery for a while. Next, protecting data, software and hardware is to saving and restoring setup information in CMOS, documentation, backing up the hard drive, and also keeping up OS rescue disk. It is also used to recover lost setup information, keep hardware and software documentation in a safe place, extra copy of files made to different storage media, and also to allow to boot a computer. Next is the system configuration. A system configuration is the process of setting up hardware device and assigning resources to them so that they work together without problems. So there are 3 resources conflict symptoms. Firstly, system hang or lockout while using a peripheral device, memory parity error and parity enabled systems, and also errors and crashes of applications for no apparent reason. So to solve this problem, there are 3 resources conflict solutions, which are determine what all devices in the system are using for resources, identify the conflicting devices, and also change the resource setting on one or more of the devices. Last but not least is the plug and play and non-plug and play. The goal of plug and play, or also known as PNP, is to create a computer whose hardware and software work together to automatically configure devices and assign resources to allow for hardware changes. Devices that do not support the PNP standard can be used in a PNP system, but they present special problems. There is usually no problem using these devices with PNP, but using too many non-PNP devices can make it more difficult for PNP to work due to the large number of resources that it is not allowed to touch. Peripheral hardware is the devices that you are adding into the system must themselves be PNP compatible. The devices must be PNP aware so that they are capable of identifying themselves when requested and able to accept resource assignment from the system when they are made. So that's all for today. Thank you for lending your ears. If you have any question in mind, please don't be afraid to ask. Thank you once again and have a nice day everyone. Bye bye.